Friends, welcome to my YouTube channel. Dhanesh here. So in this video, I am going to discuss about logistic regression. So the topics I will be covering should be what is logistic regression, then why we are using sigmoid function in logistic regression. We are using sigmoid function here. And what is cos function and log loss function for logistic regression. Cos function and log loss function. So these are all the aspects we are going to cover in this video. Fine, let's start. See, logistic regression is a supervised classification algorithm. So it's a supervised machine learning algorithm. And we can, for example, it's used for classification. As we discussed, it's used for classification. That means examples like whether the email is spam or not spam, or online transactions are fraud or not fraud. See, all these things we will cover in logistic regression. See, logistic regression is used when the dependent variable is binary in nature. For example, in linear regression and logistic regression, we have dependent variable and independent variable. When I am writing y is equal to mx, see here x is the independent variable and y is the dependent variable. You know it. See, linear regression is used when the dependent variable is continuous in nature. And logistic regression is used when the dependent variable is binary in nature. And another important thing we need to understand here is for linear regression, see, the plot of linear regression is, for example, this is, the independent variable, y is the dependent variable. This is the graph for, linear regression. Generally, we represented by y is equal to mx plus c. See here, the boundary, it is from minus infinity to plus infinity. It will go like the boundary is from minus infinity to plus infinity. But in logistic regression, as I discussed, it is used for categorical, it's used for classification. So the boundary is between 0 to 1 for logistic regression. But for linear regression, the boundary is from minus infinity to infinity. Linear regression, it is minus infinity to plus infinity. For logistic regression, we are using it for binary classification. So it is the boundaries from 0 to 1. So we need to convert this graph, or I can tell you we need to compress this graph for linear regression. This is from minus infinity to plus infinity. We need to compress this graph for logistic regression. So the graph, when you compress, you need to get it something like this. That is 0 to 1. This is 0 and this is 1. So the graph is like this, 0 to 1. So this graph is, it is a sigmoid function. It is, when you learn deep learning, different activation functions, you will learn sigmoid, ReLU, hyperbolic tan. So at that time, you will be learning the sigmoid function. Anyway, whatever I discussed, it's a sigmoid function, and in math, the sigmoid function, it is, its value varies from 0 to 1. Its value varies from 0 to 1. It is hyperbolic tan, it is minus 1 to plus 1. Anyway, we are discussing on sigmoid. So the equation for sigmoid function, it is it is equal to 1 by 1 plus e raised to minus y. This is sigmoid function. So this is the equation for sigmoid function, and this value varies from 0 to 1. That's why we are taking the sigmoid function. So again, we can rewrite it as, we can substitute y is equal to mx plus z. Then the graph will be, then the equation will be, you can write it as 1 by 1 plus e raised to minus of mx plus c. This is the equation. So this is the sigmoid function, and this is the graph we use. This is the equation we use. See, machine learning model, it is used for prediction. So here we have to use the cost function or error function. It gives the error, and it is denoted by the letter J. Cost function is denoted by the letter J, and it is equal to the predicted value minus actual value. That it is the predicted value minus actual value or target value. See, a cost function, normally we define it as the mean square error, MSE, and its formula, 1 by n sigma I is equal to 1 to n y actual minus y predicted, the whole square. So this is the equation, it. See, when we square this sigmoid function, we cannot use this. See, what I am trying to say is, we cannot use this mean square error. We have used in linear regression, we were using mean square error for cost function, but in logistic regression, we cannot use this, mean square error. It's not possible, because when this here we have to square it. See, when you square this, 1 by 1 minus e raised to minus mx plus z, the sigmoid function, you will be getting a non-convex function. See, you in math, you may be familiar with the different types of functions. So when you square the sigmoid function, you will be getting a non-convex function with multiple minimum. So we cannot use the gradient descent algorithm. Gradient descent algorithm is used to find out the minimum of the cost function. It is a iterative optimization algorithm we use to find out the minimum of the cost function. So to find out the minimum of this non-convex function, that is the sigmoid function, we use very important, we call it as the log loss function, or cross entropy function. So this function, we call it as log loss function or cross entropy function. This is the function we use it here. So what is this cross entropy function or log loss function? The definition for cost. So from log loss function, the cost is defined as minus of y actual into logarithm to the base e. For the logarithm, the base is e, or a natural logarithm, the base is 10. See, logarithm of, log of, I can write it as, like this. So it would be log of y predicted, log of y predicted minus 1 minus y actual into log of 1 minus y predicted. This is the formula. See, cost function, this is the cross entropy function or log loss function. This is the way defined. So you understood why we are going for this function, because it's a non-convex function. When you square the sigmoid function. So we will use this cost function. It is minus of y actual log y predicted minus 1 minus y actual into log 1 minus y predicted. See, here we have two cases. One is the case 1 when y actual is equal to 1. When y actual is equal to 1, cost is equal to, in the previous equation, when you substitute 1 minus y actual, the second term will vanish. So and y actual is 1, you will get it as minus ln minus log minus log y predicted. This is the equation when y actually is equal to 1. See, when y actually is 0, that's with the, it varies from 0 to 1. I told you, no, the value, because this is a binary classification in the logistic regression. So when y actual equal to 0, your cost is equal to minus ln, minus a log, because why I am using is here the base is e, ln means natural logarithm, the base is 10. So minus log of anything you can take, you can express it in natural logarithm, or the base logarithm. When it is e, it is log 1 minus y predicted. So this is the equation when the y actually is equal to 1. So this is the things you need to understand about logistic regression. We discussed what is logistic regression, why we are going for the sigmoid function. See, logistic regression, I told you, it's a supervised machine learning algorithm. It's used for classification, right? So that is the important point you need to understand. For example, whether the email is spam or not, whether the transaction is fraud or not. See, like this classification, we use logistic regression. Another important point is in linear regression, it is a straight line. And why we are coming up with sigmoid function? Because see, the value where in the linear regression the boundary is between minus infinity to plus infinity, but in logistic regression the boundary is between 0 and 1. So you are coming up with the sigmoid function, because sigmoid function, the output varies from 0 to 1. The hyperbolic tan, the output varies from minus 1 to plus 1. You know that. So that's why we are going for sigmoid function. The next one is the cost or the cost function, or the so here we cannot use the mean square error. The reason is when you square the sigmoid function, you will get a non-convex function. It's having many minimum, so multiple local minimum. So you cannot use the gradient descent, it won't work here. So here we will use for the cross entropy or the log loss function. So log loss function is defined as cost is equal to minus of y actual into log y predicted minus 1 minus y actual into log 1 minus y predicted. So when you give y actual is equal to 1, you will get the next equation. When you give y actual is equal to 0, you will get the other equation. So this is all about logistic regression. Thanks for watching.